everybody can hear me now. If you can hear me, Maura, actually just use somebody.
Yes, teacher.
Okay, you can hear me very well, huh?
Yes.
Okay, then it is okay. So I'm saying, I heard that you had an issue in the morning with the network, and I've been telling everybody that the main problem we have with online classes is maybe the network, the link not working, and the rest. But I'm very happy that we are here. Now, today we are more than we were the other time. So I'm worried about the rest now, because the previous class, we were actually dealing with solubility. We started with solubility and solubility curves. So I don't know, because now I'm supposed to be starting, I think I'm supposed to be doing uses of importance of solubility curves. But there is a question that I had given out in the group, which I'll use somebody's, I'll use the graph. Somebody sent me a graph, which was very well drawn, if I might even add. It was very well drawn. I don't know if it is possible that I share it to the group. Is it okay if it is shared to the group? I think it was
Yes.
Maura.
Maura.
I think it is.
Yes,
Yeah,
it's
yeah,
okay.
yeah. I want so that everybody can see, since I can't share it on my screen because I had not really sent it to the computer. I was not around also. I just came in. So I shared the question. I don't know if people actually got so I think it is in the registered. Let me just send it to that one. Yeah. I've sent it to the group. I want you to see that graph. So I don't know. I'd shared the question. I think I can do the same thing. I think it was not in this group, the question, but I can look for the question so that you see how we draw the graph, especially for those ones who are not there. But this one was a very good graph. I have not shared mine, but this one is a good graph, a very good one. It has followed the rules. So let me share the question also so that we can answer maybe 2 or 3. If you have the question now, come on, as a part of swali before me, I think you can still share it. It is okay. I think it was one question. Have you shared it? It is okay to the group. Just put it. I hope everybody can access the group at the same time being class. I think we just you can minimize the live one and then you look at that graph just for a few minutes as I look for the question. I don't know, anybody who has gotten the question? If you get it before me?
I have
Yeah.
Mwalimu, but penye niko network inasumbua. I don't know if itafika.
Sorry?
I have, and I've shared it. Though the issue, I have an issue with my network over here.
Mutindi, can you hear what I'm saying?
Yes, I can, but I'm saying, hello.
Can you see this? Yeah, I am hearing you. Can you see the screen? Yeah, you are very low actually.
Yes, I can. Though I have an issue with my network.
Okay, I think it is okay because the good thing it is being live streamed, so you can go back to it. But there is no problem. If you have an issue ya network inaeleweka because it is an online process. But are you aware of what you have been doing previously?
No, but I try to catch up with the people. No,
Okay.
I haven't been at. I'm out of the country
Okay.
for work thing, but I'll catch up
Yeah.
with you.
Okay, then it is okay. But if you have a question, I think it would be better if you just pass it to us so that we can try and answer. The ones that we can answer, we answer. The ones that we can't, then we leave it for the next session or something. So there's no problem. I think I can understand you. Anybody else with a problem before I continue? So Marietta has an issue with the network. Understood. So if we are okay. Now I was looking for that question. I think it has been shared. Has it been shared? Yeah, I think it has been shared. Thank you very much. Now that was the question actually. So the question was saying, if you can see what is meant by the term solubility of salt. So for the sake of those who are not there, we can repeat the definition of the solubility of salt. So we said when we're talking about the solubility, we are talking about the three sections or two very important. Let me just say two so that I can combine the other two. So there are two very important sections that we need. You're supposed to talk about the mass, and the mass should be in grams. All that is very important. And then we are supposed also to talk about the temperature, the particular temperature. So we talk about a certain temperature, constant temperature. If I'm moving too fast also, you can say something. So we must talk about the temperature. That is for the first question, that is defined solubility. But I'm not interested in that. The question I'm interested in is the question now that is coming down there, which is saying, then the next question I think we'll still do another question, which is saying calculate the solubility of a salt given that. Yeah, I'm reading very fast because I think everybody has the question. Yeah. And then you have question C is the one that I was interested in. Plot a solubility curve of salt X. That is, they're saying solubility in grams per 100 grams of water, by the way. It is on the y-axis. So this one, I'm saying the question was very easy because they gave us the y and the x-axis names that will be done. And then, and temperature on the x-axis. So the graph, I want us now to go back to the graph. Now, everybody yako kwa graph. The thing I was talking about this graph being good, first of all, amefuata the rule that we mentioned. You remember nikisema, if you think your graph is gonna be too big, make sure that you skip two boxes, two 10 boxes, the smaller 10 boxes. So I'm gonna skip two for naming. Are you seeing it is taken care of? One side is taken care of. That is on your the y-axis. Let me say the y-axis, where you have solubility in grams per 100 grams of water. And then chini pia kwa temperature I'm skip. So I'm skip here the two boxes so that it can have. So when you're plotting the graph now, I am zooming the same graph. Of course, I didn't share because sijatuma kwa laptop. If I had, it would have been better. I would have explained better, but I'm zooming. So as you can see, the points they have plotted using X crosses or the crosses. So make X kwa points. I said we should not use a dot. Actually, this scale is good. The scale is fairly good. She's covering at least 3/4 of the page, so that scale is good. The scale, I think she even went ahead and said, give us the scale, which that is top notch. I think I may add something. And then, so you plot the graph, plotting the curve now. So you have plotted the points, and then you plot the curve. Now, this curve is fairly good. For me, it is fairly good. I would have given it 90%. So she did a very good job. And I hope that, and then there's something that I'm interested in. From the points, actually, they were not given, I think they were not given the 0 point in the y-axis or the x-axis where we have 0. So I'll extrapolate. That is what we had mentioned. We don't leave the graph hanging. And lakini hakuchora na ruler. So we were not, it is the solubility curve. So this one was good. I don't know. I'm also having a problem with my internet because, but it is okay. If I nikipotea kidogo, if I get lost kidogo, you just say something, because I moved to another place. I'm not actually in my home, so I'm in another place. So now something else. Now I want us to answer the question. So we have the graph. I think somebody will answer. The best person to answer for us is the one with the actual hard copy, but we can also follow. What is meant? So we are going to question 12, C2. I'll skip that one because it is very easy. What is meant by the points plotted in one above? What is meant? What is the meaning of those points? What is the meaning of those points? So those ones, the meanings, I think the meaning is very easy. The meaning we are saying, I think I can explain that one. So I can say those points mean it is the solubility of that salt at that particular temperature. So as the temperature is changing, also the solubility will be changing, as you can see. So it is the solubility increases with increase in temperature. That is what we said, factors affecting solubility previously. So it is increasing with, the solubility of that salt X is increasing with the temperature. So that those points means it is the solubility of that, but I'm not interested in that one. What I'm interested now in question number 3, where it is saying, from your graph, determine the solubility of salt X at the following temperatures. So we have 44 degrees. I think I'll just do that one for the sake of because of time. So at 44 degrees and 62 degrees. So we go back to the graph. I want people to share that one. Let us just share that one before we do something else. Please share what is the solubility. What is the solubility of the salt at 44? I want something so that I can do something there. And then I will explain using my quiz, the one that I have just opened. If you can see the screen still. So what is the solubility from the graph? Determine the solubility of salt X at the following temperature. So number 1 is 44 degrees, and then number 2 is 60. I want somebody, in fact, Mauro, you can help us with this because I know you have the hard copy. We have not printed, some of us. So ours is soft copy, but I will use the one on the screen to explain what she has done. So that is okay. I hope that is okay. So from your graph, determine the solubility of salt X at the following temperatures. We can even do one, and then I can explain the second one. So 44 degrees. I want you to do for us. Yes.
16.
Yes.
At 44 degrees, the solubility is 16.
I don't know. Do you have the graph with you?
Yes, the hard copy.
Yeah. Have you drawn something? Have you drawn something on that graph?
Yeah,
Please, can you? Is it okay if you can share the photo to the group? Please share a photo to the group.
Okay.
Yeah. I think that will help us a lot so that I can explain easily on this other side. Yeah. Please let us be patient because I wanted to, actually graphs. I'm normally very particular with graphs because they are very dangerous and it affects both of my subjects, physics and chem. So I normally teach it with intensity because it will be there. Now I realize that it is also in biology. I never took biology myself, but I realized it is also something that will bring a lot of issues in biology, also mathematics. That is why I'm normally interested in doing that one deeply. I hope you don't mind. And if I'm moving too slow for you, you just also tell me. Yeah? So I'm waiting for that one, and as she's sending that photo. Now that graph, as you can see, this graph, mine is correct. The reason I left out something, I think it is already in. Yeah, if you can see what she has done, I think that one is a good job. Yeah, actually, that one is a good job. And actually, let me just tell you, this graph, all of you are correct in the graph. The only problem that normally comes in is if you did your plotting wrong, then you get the wrong answer. But if the plotting is correct, all of your answers
Hi, Domitila. Domitila,
Yes.
how tight is the schedule?
I'm also waiting for the teacher.
I'm asking how tight is the schedule, being that last week I was not around. And it seems like this week and next week I might not be around here. And I can see that anything to do with availability uko sawa. So I wanted to know how to is the schedule so that I can schedule time na wewe unisaidie kwa hiyo class yenye mlisoma last week.
I don't know because during the day I'm always busy. But on Sundays, I'm usually free after church.
No, ni sawa basi. I think ni kitu naweza take like an hour plus an hour and half hivyo. So iko sawa, ndakutafuta.
Okay, no problem. Okay,
Sawa, thank you.
Okay.
Kwani mmekimya?
By then we can continue. Teacher amesema we discuss. We can be doing something before the teacher comes connect. But
Sure, being that wako sawa, able to
kama hiyo sasa about solubility ku draw a graph is not naacha makelele, nifungie hiyo mlango, si kitu ngumu sana cause umepewa readings, ni wewe sasa ujipange the graph kulingana na venye teacher alituambia. Make sure you use a 3/4 of the given page. Make sure umepanga the what do you call it, the scale kulingana na venye unaona itatoshea more than a 3/4. Kama hiyo tulikuwa tumepewa ilikuwa very obvious. So ukipewa maybe kama hiyo tumepewa 42, unaenda unaangalia mahali 42 yako iko, unapanda nayo mpaka mahali point ya curve yako iko. Ukiguza that curve, then you go to the y-axis. The other one tulikuwa tumepewa 62, unaenda unatafuta mahali 62 yako iko, panda nayo mpaka mahali itaguza graph, then unaenda mpaka side ya y-axis, then you get the answer. Sijui ka imesaidia hiyo kidogo.
Welcome back, Mwalimu. I've made you a co-host.
Yeah, I don't know if I'm the only one who experienced the same problem. I think it could be only me because I was not using my phone.
Tuko tu sawa.
Okay, no problem. Then we can continue. Let me look for the documents very quickly. Now, as I was saying, when you're talking about the Now let me find a way to share the screen first. Now, when we were talking about that one, I'm seeing again, Maura, I think you have done a good job while I was away. I think that is now, those are some of the issues that we have with maneno ya internet, which is okay. I think it is understood. So, so whatever you have shared, I'm seeing that you have shared. I wanted actually the actual value of that one, which I don't know if everybody can see from the graph that has been sent to the group, because we're using the one that is in the group and the one that is the question. We have the question, so we were using both of them. So I don't know if people can tell me the actual value. If you have already discussed the better, but you can tell me the actual value of both, of whatever we have gotten, as I share the screen. Let me please, and we are sorry for that inconvenience. So the actual value, Maura, I think you are the one who has the hard copy. I'm seeing the one with 60 is about 25. Is it 25?
Yes, the one with 62, it's 25,
Yes,
and 44 is 16.
44 is around 16
16.
there. Yeah.
Yeah.
So I wanted to show you how we can. I think everybody can see what I've just placed on the screen, what I've shared, because I wanted to use this one. I wanted to show you on the screen how it is done. So actually, again, I want to congratulate Maura because she has done a good job kuonyesha hivyo. So that is the right way of showing. In fact, if you know that you unaweza tense, you can draw a full line. It is okay. We are allowed to draw a full line. You can draw a full line, full line. You just draw a full line. But for you to get it correctly, please do not write an answer. For example, if they ask me, I wanted to draw before we had that problem. So you let me draw it in the middle. So if they ask you about the temperature, sometimes they ask you the solubility when the solubility is at maybe 60 or 40. So what you do is unakuja tu pale 40 iko, you do using a ruler, please. Now hapo ndo mnakubalika kutumia ruler. When you're dealing with the curves, I said you are not supposed to draw using a ruler. So the only places you are supposed to do using a ruler is the axis, which is the y and the x axis. Now after that, unaweka sasa, ukishaweka x and the x, wachana, don't use dots again. For those who are not there in December, you do not use a dot. So hapa iwezi kwa dots, so inakuwa x. Unachora where it touches the curve, hapo you change the ruler direction. You make it vertical now, or you make it horizontal, depending on the question. Question yetu ilikuwa inaanzia temperature to solubility. When it starts from solubility to temperature, you do the same thing, then you draw. And then now, after you have done that, you write the answer on the question paper. So pale walikuwa wamesema 44, I think it was 44. So where they have mentioned 44 degrees, you say now the answer, but the answer could be correct juu ulitumia imaginary lines, which is okay. But as an examiner, I don't know where you got that answer. There is a possibility you copied the answer. So make sure umechora. Just do this drawing. Chora tu, pali inakutania, iteremuke. Just show. That one is the most important thing. I think that is all about the graph. I wanted only to show, but Maura, you have done a good job, and thank you very much for giving us that one. Is that okay now? Kila mtu ako sawa? So that we go. So what is the uses of these ones? The other time when we were in this class, I said we have uses. That is another name. We have uses. We have the importance. Somebody else can say significance. So significance, and this one, especially, I don't know if we have physics students. In physics students, I will not ask you about the importance they uses. I'll always ask, what is the significance of that graph? Or what you have drawn? What is the significance of the, for example, what do we call this one now? The gradients. when you calculate or when you do the gradient or the gradient, what will be the significance? So that one, so uses importance, significance. Don't forget those three words. Most probably the questions that will be, or the term that will be used in the questions. So of solubility, so number one, solubility curves. This question, I don't know if it was in the KCSE last year, but there was an exam I saw this question. They asked what is the use of solubility curves? So there, the solubility curves is used to predict whether, predict what would happen or whether a solution would form crystals or not. So we predict whether there will be formation of crystals from a solution. I don't know, a lot of English has been used, but it is the same thing. So you predict, there's somebody who asked me last year. Yeah, one of my candidates told me, can I say we predict whether a reaction will occur? Yeah, that was a good one. Yeah, so we can predict whether we can, of course, I think in chemistry we have that thing that is called a reaction. We only know, most of us wanajua reaction ni kitu inakutanishwa and then it forms something else. But actually a reaction is anything. It can go the other way around because you normally say we have backward and the forward reaction. So it is the safe to say it predicts whether a reaction will occur or will be becoming. So those solubility curves are used to predict what would happen to a solution when heated or cooled, whether the reaction will occur, whether the crystals, because a reaction that leads to formation of crystals. So you can say it is used to predict whether a reaction will occur. We will talk about that one. There is another place that we are talking about uses, and then we will say it is used to predict whether. So it is used to predict whether we will form crystals. Okay, another use, it is used to separate mixtures of salts, which is different, which is actually the best use, actually in fractional crystallization. I don't know if you have done fractional crystal, but I think it is below. So fractional crystallization, I'll give you a very good example that you already, I don't know, but you have an idea. How we normally trona from, is it trona? We have trona, and then of course you have like magadi, extraction of sodium chloride, which is chumvi yenye tunatumia nyumbani. Actually, we use fractional crystallization where we have something in the evening when it is cold, and then we have something else during the day time jua inawaka. So when it is hot, there's something that dissolves, but when it is cold, doesn't dissolve. I don't want to explain so much about that one, but now this one actually is the best use that has been applied. Real life application. Ingine ni lab application. We are using it in the lab to predict whether something is happening. Let's do one example for the sake of just we remind ourselves. Watch it to remind ourselves. And these questions are normally there. And for those ones who are not aware, I was just checking on the group, and then I realized that tumeunda group ingine, which is okay. So I'll share these notes to that new group, and also the questions that I shared of all the Form 4 topical questions. I'll also share for the other classes. We should not be worried because we are doing tunapitia. So let us do this. I think we can do one example and then we do something else before we learn something else. If you have a question, if kama hujaelewa kitu, please raise. Please niambie. Because I think I just realized we moved a little bit faster because of the 10 minutes that disappeared. So we can continue. So example number 1. At 100 degrees Celsius, the solubility of salt X is 80 grams per 100 grams of water. At 20 degrees, the solubility is 42 grams per 100 grams of water. Remember, the unit of solubility is grams per 100 grams of water. That is why you'll be seeing 80 grams per 100. 40 mara mingi it will be repeated. Now, if initially it was saturated and the solution filtered at 100 degrees in 100 grams of water, then cooled to 20 degrees. The question now, okay, kumbe the question I just kept. So how much salt? So what mass? The question could have come at hapo chini and say, no, what mass would be formed? What mass would be formed? So when you're given a question like this, And I think we have a question in the zile maswali nilituma, kuna swali kama hii where we have two salts and then you ask gani ina separate at these degrees mapema, but this one is one salt. So what you do at 100 degrees, it is 80 grams that is being formed into in a dissolve. So at 42, at 20 degrees zenye ina dissolve ni 42. That is what saturates that salt at 42. I want to do using I want us to go back to that graph for the sec. Now this one is the reason why we need to be. I wanted to see in that graph that was sent. Let us just use that, the graph that was sent. And I want us to use the one that was sent ya mwisho, where we have where we are told the solubility at different temperatures. I want us to see, because it is almost the same thing. So we are changing the at 100 degrees, we are changing it to at 60, is it 64 or 65? To at 66 or 60 something. And then we have at 40, 44. I think I remember 44. I think the other one, I think it's 62 or something. So at 62, let me just, can I rub it so that people can understand what I'm talking about? Because you have that graph. Sini niandike. I hope that is okay. And kama imekataa, you tell me also. So I want to say at, instead of that one, niweke ile yetu, I think it was 62. So ni 62.
62.
It is 62. Yes. So 62 degrees Celsius. And then I rub this one also na niweke 44. So that we see how this question is being done. Because you already have that one. So sometimes, so solubility is 8. We can even leave that one at that. But why don't we use the one that we, let us just use. So tulikuwa tumesema hapa ni 25. So this one become 25. Alafu ya pili, I think you can help me Maura, because ya
16.
pili ni ngapi? 16.
16. Yeah.
Yes, 16. Okay. So the solubility at 62 degrees for that thing to saturate, in a saturate 25 grams. Okay, reduce, as you reduce the temperatures, ukiteremuka, adding to 0. Yenye ina dissolve. I'll use a very good example. Let me just give an example before even you go here. Ukiweka chai sukari ikiwa boiling hot, na uweke sukari ikuwe saturated, you know ile yenye mtu anasema ni kama imewekwa asali or imebadilika, the tea is like asali. When you do that, na uache hiyo chai ikuwe baridi, do you get sugar baadaye chini imesettle? Yeah, I want that one to be answered. Umeweka chai sukari ikaja kabisa, ile imejaa mpaka it cannot dissolve anymore. That is what saturation means. Umekoroka mpaka haiwezi dissolve anything else. Yeah. Alafu, and it was boiling tea. Alafu ache cool ikuwe baridi. Do you get settlement down ya sugar after ikikuwa baridi? I think this one is a practical session where I think it can be done at home. I want you to try, even though you're cooking tea maybe in the morning, weka sukari mingi. I'm not saying you unachota chai kidogo na weke sukari yenye utaweka, and then you koroga mpaka ikue saturated, and then you transfer a little bit to another cup na uache ikue baridi, maybe even for maybe 30 minutes, and then you pour, uone kama imeanza kuform nini, crystals. So at different temperatures, remember, when you're talking about the factors affecting solubility, one of them was temperature. Na tukasema, as you increase the temperature, solubility increases. I don't know if somebody is saying something. Let me check, because I didn't join with my yes, I think James has answered that question. So the sugar will be deposited at the bottom after it has cooled down. Yeah, that is exactly what is happening. So we are reducing, when you reduce the temperature, thank you very much, James. So when you reduce the temperature, you are making something come out. So at a certain temperature in a deposit meaning. So this one, what you do is at the highest degrees, the mass is 25. At the lowest, it is 16. So the mass that will be deposited will remain. It is the one that was saturating the higher degree. So you minus the upper and the smaller one, just like that. These questions are normally very easy. So you do so for our case, which we withdrew, the graph, it is 25 minus 16, which now becomes 9. So the mass that will be, how much will be deposited, or the mass that will be produced when we cool from a certain temperature to a certain temperature, you minus the highest minus. So from ours now we get 9 grams. Iko sawa mpaka hapo? I hope everybody ameelewa. I didn't want to use this one, but we still can use this one. Let us do one example and then we go to something else very quickly. I really wanted this topic to end. So question number 2. Let us try question number 2. What? So I'll not give you the answer of question number 2, but I'll just roll so that we see. I don't know if that one is okay. Yeah, I think that one is okay. So salt X and Y mixed together and dissolve. Now this one is a mixture. That's why I was saying we have another question somewhere. And dissolved, mixed together and dissolved to saturate 100 grams of water at 100 degrees. The solution was then filtered. This solution was not cooled to 30 degrees. The solubility of X is at 100, at 100 degrees is 80 grams. So if you 100 degrees in a dissolved 80 grams of that salt. Now at 30 in a dissolved 36 grams. The solubility of Y at 100 is 100. And at 30, 50, what is the composition of the mixture of at 30 degrees? So they're asking, actually the question is saying, ni salt gani itakuwa na mass gani? So can you try? Is it okay if you try this one? If you can, if you cannot, please you can still say, and then I solve it. I will explain it, but I wanted people to try. What is the composition? You'll say it is 80 grams of this one and 30 grams of this, or 80 of this one and 40 for this one. 80 for X, 60 for Y. That is the composition. That means it has 60 grams for this one. I don't know. Can you solve it? Maybe somebody can say something. Do you think you can try that one? Can you, Maura? Is it okay if people can try that one? I just want to know if people have understood so that we can move to something, but I'll still solve it. James, is it okay to try? I'm just reading the names that I can see. I'm not. I hope I'm not targeting anyone. If somebody is feeling targeted. Do you think you can try? Before I do it, of course. Wendo, Daniel, I think Daniel, Monica. I don't know if you can try. But I'll do it. I still do it. If you can, the better. Then you can share it on the group again if you cannot. If it's okay, you can chat on the group. That's why I check the messages. Or we just solve it together. The same thing. I think that is okay. So let us solve it because of time. Because I have not said anything, so we can solve it. So actually, this thing is very easy. So I was saying this one is very easy. But at 30 degrees, you minus yenye ni mingi, the temperatures. So you minus, so you have 80 minus 36 from the question. Actually, the question, the answers are in the question. So the only thing that you're supposed to do is to contemplate. Ukishafikiria vizuri, you just have to the salt that is remaining contains that one around 40. Is it 44? And you must mention that it is of X. And then the other one is Y. Sijui kama sasa iko eri. What you get there, yes, because actually this one is factoring in the factors affecting that one. So I hope kila mtu ako sawa. If you are not okay, I will still answer some questions. I'll still answer some questions. If you are not okay, I'll still answer some questions. I'll still help out. If you have a question, I said you can share it, you can answer the question, or you can share the question. Just inbox me. I'm available in I think Maura is a witness. Na reply messages, I answer questions there. So the solubility of potassium nitrate at 20 degrees is 25 grams. I'm leaving out the units, 25 per 100 grams of water. And then it's saying how much will dissolve in 80 grams of water at 20 degrees. So actually, these are things that we have already done. So I think you can try those ones. For those ones who have the, yes, let me check. Somebody has, yes. So it is okay, James. That is why I was saying it is okay to share on the. It is okay on the. Thank you very much, James. Actually, those are the correct answers. So I normally tell people that in chemistry, especially the upper classes chemistry, that is Form 4 and 3. This one actually is a Form 4 topic, the first topic in Form 4. Now, in Form 4 and Form 3, the best way, especially the first topic, especially in Form 3, the first topic, which is gas laws and the mole, it is very important for you to do a lot of practice. More practice, more results. Few practices, I don't know, it involves a lot of calculations. That is what I'm saying. So the more you do it, as you can see, this one has a lot of calculations. The next topic, I think, is called energy changes. So those are questions. I'll share the notes. I hope it is okay with you if I share the notes with the group now. I'll share the notes with the group, these notes. And then you can try the questions. You can try from question 4, question 3 actually, 4, 5. Alafu munitumie, I can mark for you. We can discuss. If you have an issue again, we continue. Fractional crystallization, which is one of the applications. So this one is the application of the curve, solubility curve. This one is the application. So this one involves separation of soluble salts. We are separating two salts. For example, if by mistake, umemix magnesium chloride na sodium chloride kwa nyumba, how can you separate? This one is actually an application. How can you separate them? This one. So this one we boil, we add the two salts in the same solvent, for example, water in that case. And then we boil them. I know you know the meaning of boiling. Ichemuke kabisa. And then we cool slowly. One of them will crystallize faster than the other. Now, when that happens, one that crystallizes faster than the other, that means you can remove, you can now use the decantation method, you can use the filtration method to separate this residue from the solvent. Or what do you call the solutes now? I'm saying the solvent because it will be in liquid form. So you remove the residue, which is the crystals. I think this one will be done in Form 1, separation of mixtures. So we remove the residue from the solute, where the solute now will be the one that has not crystallized, while the crystals are the residue, and they are separated. There are very many methods of separation. You have decantation, ile ya nyumbani. Ukipata mtoto ameweka mchanga kwa maji, do you pour the whole water if that was the only water? No. What you do is you let the soil isettle huko chini na umwage pole pole. That one is decantation. Filtration, I don't know if I have a video. I'll check if I have a video of how you use a filter paper. I do hope I have a video of. I really wish I do, because it is very important. Because they normally give you a filter paper in the practical, so you can filter. So crystallization, actually, now we come back to this one. So we say crystallization is the process of forming crystals from a saturated solution. So when crystals are formed, you can separate crystals, which is a solid in form of residue, from the solute, which in that case now is the solvent. So that one is, and it is one of the best methods of. So we can define as we are separating what? In which solutes are separated from each other according to their solubility in the same solvent. That was the first thing I started with. Tunaweka hizi vitu zote kwa the same solvent. That is number one. And then you boil them to a certain temperature. Now, as they are cooling down, one will crystallize earlier than the other because of different solubility rates at different temperatures. So at different temperatures, solubilities of salts are different. That is why that is now fractional. can be extracted through fractional crystallization or can be acquired by fractional crystallization. Sorry about my internet. I don't know. Here's a few. I think it is okay now. So I'm saying anything that has two salts, that has two salts, or that is a complex salt, or that is a double salt. Remember, we were talking about salts. The reason why we decided to cojoin the acids, bases, salts, and the acids, bases, and salts in Form 4 is because they are relatives. They are cousins. So tulikuwa tunataka iendelee so that when I talk about now, can you give me an example of a double salt? One of the examples of a double salt, I think I was the one who taught that one. Actually, I think I was the one mwenye nilifunza hiyo. An example of a double salt. We just mentioned it so that so that it makes sense what I'm going to say. An example of a double salt. Anybody, you can even write an example of a double salt. Yani tunakumbushana, so we are still practicing. But in revision too, because example of a double salt. A double salt, a double salt, a double salt. Any example, actually. Example of a double salt. Example of a double salt. Yeah, I thought those ones. I think I was the one who taught those ones. No, you are making me worried that maybe sijui kufunza vizuri. Or maybe I'm moving too far or something. I don't know. But you are making me worried now. So double salts, a very good example. I even said there's only one example you're supposed to remember.
Potash aluminate.
Yes. Yeah, that one is actually, that one is a very good example. I didn't mention that one. But we said these salts that have ions, they have two cations or two anions. Those ones are the things that we were talking about double salts. So if it has two yes, yeah, ion 2 ammonium sulfate. I think it was ammonium ion 2 sulfate.
Yes.
That one is the one that yes. So it has ion 2 and ammonium. Those ones are positive ions that are 2. So another good example. So those salts that have 2 ions are called double salts. And if there are 2 salts in themselves together, for example, trona is normally a combination of 2 salts. Na tulisema hiyo somewhere. I said the best example you can give, kama umesahau kila kitu, give trona. Wakiuliza tu sema trona. So extraction of trona is one of the best applications of fractional crystallization. Remember, I don't want you to get confused. In fractional crystallization and fractional distillation, tafadhali tusichanganye hizo vitu. Crystallization and all of them utilizes temperature. So you increase the temperature, alafu as the temperature is coming down, you are filtering others, you are removing others outside. So it is the same process, but the other one is crystals and the other one is distillation. Can you distill a solid? So it is quite difficult, but we can distill liquids and liquids, or let me say fluids, because fluids is gases and liquids. So you can distill those ones. So manufacture of sodium carbonate in solvent process, I will not talk about that one. I'm saying tutarudia pahali. That one is number 1. Extraction of trona from Lake Magadi, which is a different process. And then we have extraction of sodium chloride from seawater. Now I know we extract that one from Lake Magadi, but when you have seawater again, you can. And these are now in different countries. These are different points because of Lake Magadi. Actually, we only know Lake Magadi ourselves because we come from Kenya. But now, when you go outside, they don't even know. So they have other sources of salt. So that is why we are talking about sodium chloride. So it is normally extracted from seawater. That one, the reason why I'm just mentioning them is because it will be repeated. Iko sawa? So, for example, extraction of sodium chloride is repeated in form 2. It is a process by itself. Trona, we repeated inajisimamia. It is a solve process actually is a full process. The first process that we are going to get, I'm normally tell students, the first process from form 1, ukiingia form 1, form 2, process ya kwanza came tunapata ni solve process. That one is the first one that we are going to get. So solve a process. So that is why I'm not going to touch on it, but those are the applications of crystallization. And the good thing is I'm going to share the notes again. So iko sawa. Now, so that we continue. Now, we have examples again at 25 degrees sodium chloride. So examples are calculated actually. So I think we can just, it is the same process that we use, but now this one is, yeah. So this one is better. So at 25 degrees Celsius, sodium chloride. So at 25 degrees Celsius, the sodium chloride solution in water starts to crystallize when its concentration reaches 28% by mass. So actually this one is percentage. So you should know that 28% means over 100. Calculate the solubility of soda in grams per 100 grams of water at 25 degrees Celsius. So I want you to remember when you're defining solubility, I normally like going back to definition so that people can never forget. So we are saying at 25, solubility is at a particular temperature. So this one they have said at 25. Now ukumbuke mwisho wamesema at 25. So the particular temperature is room temperature actually. 25 degrees. I think there is a place where we'll be talking about STP, standard temperature and pressure. And then we have RTP, which is room temperature and pressure. So I can say this one is RTP. It is room temperature. We normally say room temperature is around 25. So you must calculate and then you now get the answer. So it is 72 grams. So 72 grams. And then you remember it is 28% of it crystallizes. So it is very important for you to, you manipulate those ones. You must manipulate the percentage. When you're given percentage, it becomes very easy. It becomes easy. I hope we are tuko sawa. I don't know. I don't know if it is the network problem because we just became very few in class. And I get worried when I have very few students. I know network sahi inatusumbua kidogo. I don't know. But I thought it started in the morning. So there's no problem. We just continue. But I know better days are coming. So better days are coming. So, so another one at 29 degrees. If you don't understand something, you tell me. Sodium chloride in water, in sodium solution in water starts to crystallize. And these questions, they are the same. What you're saying is we are starting to crystallize. That is the only difference with the other one. In the other one, we are just saying the temperature as it cools. Now, what mass will be formed or how much of it will be formed, which is the same thing. This one, they are just giving us the fact that we know fractional crystallization. So they are telling us it crystallizes at this place. So concentration 25 by mass. Calculate the solubility of sodium chloride. I want us to understand something before even I continue. I want us to understand something. I want you to understand that when you talk about, because I'm seeing now, I just realized that let me explain you. Let me just underline something. 5%. Now, 25% by mass, we are assuming that what is 100% by mass? It's in 100 grams. I want us to understand there first. So 25% by mass means the 75%, is outside. I want you to understand something. So when it crystallizes, when you say it crystallizes 25% by mass, I wanted to take us back a little bit to Form 3 work. Hopefully, I hope everybody has an idea of that thing. We have what we call the empirical formula and the molecular formula. So in the empirical formula and the molecular formula, we'll be talking percentage mass. So wakisema 25% of this is hydrogen and the rest is oxygen. So you will assume that 25% is 25, so the remaining is 75%. So 75% is, so that is the same thing. I hope watu wanakumbuka hiyo story. But I know we will do it again, but I wanted to remind you that when you talk about 25% by mass, there is no problem. 25% by mass means we are talking about 100% mass, and then 25% now is out. Yeah. So sodium chloride solution in water starts to crystallize when its concentration reaches 25% by mass. So if it reaches 25%, that means you have 75%. So and then we do now that one at 75 grams. So calculate the solubility of, I don't know if people wameelewa what I've said there, especially, but I wanted to use the other one so that it becomes easy. The one that I was talking about, empirical formula and the molecular formula. I think when I explained it that way, it becomes very easy. So this by mass, we are talking about the 100% mass actually will be a 100% mass. So 100%, let me just write this one. 100% is equal to 100 grams. So it is equal to 100 grams. 100% by mass. So if I wanted 75% of this one, I will say 75% without even a doubt is equal to 75 grams. Because we are talking about in grams per 100 grams. So we assume, of course, in chemistry, we don't normally talk about assumptions, but there is assumption. So when we talk about 100%, we know that 100% means the full or the complete dose. Yote imeenda. So that one is why we normally assume that people will understand 25% by mass. So that is how we calculate. That is how this 75 is coming. So you should not be worried. So 75% is 25. What about now 100 grams? When we crystallize all of it, what will be what will dissolve? The 100% of it in a dissolved sasa in that one. So that is how you do it. Sijui kama mnaelewa kitu nasema, so that it becomes very easy. And these questions are normally very tricky. They're normally very tricky. Especially you can see that it is actually tricky. That is why I had to solve this one. So when you talk about that one, as you can see, ukiona hapa what I have done. Let me just go back a little bit. So nimesema what I've done here is the 78 grams. We are talking about 28% by mass. So when you do 100 or you do 72 plus 28, nengapi? 100. So when you talk about 72 grams, you're saying those ones are outside. Now 28, we are saying is the one that has crystallized. What about now 100 grams? It had dissolved ngapi? I hope you are getting that one. So 72 grams is happening. So what about 100 grams? That one is very important. Now, there are two methods of explaining these ones, but you end up with the same answer. But I normally say, I would prefer always the students to choose the easiest one. The easiest one, the better. So these questions are normally there. And I think it is there in the other one. I'll look for it. Again, I'm saying I'll share the questionnaire. Zote zenye nilituma. There is no problem. So that we can practice. If you have a question, inbox. Just share it inbox. So as you can see, when you add the 2 on top, 72, 28, that is 100. 75, 25, 100. So there is that relationship. And then now you calculate the percentage in 100. So the bigger percentage now. Then you get your answer. Sijui kama watu wako sawa. I don't know if people are okay. When you're given a question, now this question is very common. Question number 3. Let me check. Somebody has written something. I don't know if somebody has written something. Yeah, okay. James, it is okay. So these questions are very common. These ones are very common. Actually, and the way we solve this one is the same way we solve the. You remember when a question to solve at 100 and at 80, where you have a certain mass coming out. It is the same way. So it is the same way that we solve. So you know the mass that will be coming at the mass of this one. Then they will ask you which mass, which salt will form a bigger or a heavier, or which salt is formed, at larger values, or ni gani itaundwa mingi, depending on that question. So if the mixture is cooled slowly from 15, name the calculate the mass of the salt that will crystallize out. So yeah, so yenye itakuja out mapema, or they will ask you which one would crystallize earlier. Now this is a question that will come out. I think you can try that one out, and you already know how this one is done. I think you can do this one. This one is very easy. This one is very easy from the questions that we did previously. But why don't you try this one? Can I leave it so that you can screenshot? Can you screenshot this one? Or you can take a picture of this one? Or can I take a picture and then I send to the group? Let me take a picture and then I send to the group. And then we try, and then we will do this one. So we'll try that one. So yeah, okay, I'm sharing that one, and then I share the question. Please let me share onto the group. There's no problem. Wacha ni share, alafu tutaanzia hii. I really want us to do this one. This question is normally very rampant. In fact, if we are going to do a cut, this question will be there. I'm very sure it will be there. So I've shared to the group. So the two pictures I could not take because of the screen. So I've taken two pictures. The first question is the first part of the picture is the question. The sketch of the question, alafu the actual question ni hapo chini. See, that one is okay. We can try. Ikikataa, you just come to my inbox. I think we'll guide each other. Tunasaidiana tu. Any query? Any query before I start? Something that is now there are a lot of words that have been used here. A student of mine was asking me the other day. Now, how do I know that water is hard? Ama nitajua just in Kiswahili, which doesn't make sense. So nitajuaje maji ni ngumu? That is what he asked actually. Nitajuaje maji ni ngumu? Now, there are very many methods of knowing that water is hard, and it can be tested in the lab. We are going to see on them today. Now, when you talk about water hardness, actually in Africa, I don't know if it is life or it is something else that has made us know that anything that is hard means it goes to students. Of course, this one goes to the children, the younger children. They normally think that hard things means kitu ngumu, for example, a chair. So actually, when you talk about hardness, you're talking about impurity that what the impurities that are, let me just use impurities that are in the water. Now, there is a difference between hard water and soft water, and I normally give out this one categorically for the students, but let me just mention it because we are in this topic. We have dirty water, which is soft water, dirty maji chafu yenye ni soft water, and we have clean water, which is hard water. So water can be clean, but it is still hard. Water can be dirty and still qualifies as soft water. so that sometimes a teacher can say we have dirty water that does not have certain ions. Is it hard or soft? We say now that water is soft. Hata kama iko na uchafu inakaaje, we say it is still soft water. Now, hard water, actually, something else I am supposed to mention before we continue. Hard water has better advantages. Nasemanga maji, without hard water, most of us would not be alive. That is the statement I can use. Without hard water, hiyo water hardness sasa, hatungekuwa alive. Hard water, importance of hard water outweighs its disadvantages. Let me just mention it that way. Importance zake in outweigh the disadvantages. So hard water is very good for us. So water can be pure or impure. So there's no now remember that water. I wanted to remember the chemical formula for water, H2O. So that one is what I was talking about. And when H2O now, without anything else, its density, the density of water is 1 gram per centimeter cube, or 1,000. I think I had mentioned this one previously. It is 1,000 kilogram per meter cube, and that one it is proven it is true. Those things are the same. 1 gram per centimeter cube is equal to 1,000 kilogram at sea level. So when you say now water is impure, we have not added sugar. Actually, sugar in water can be still soft water. So when you talk about water now becoming hard, is we have added 2 things. So we normally say, I will not describe a lot of these, because we are really interested in something. So we normally describe hard water. So this one is the description of hard water. And it's hard water. I will not also, there's something I'll skip for the sake of bringing it later on in the. So hard water, this one is the definition of water. Hard water is water that does not lather readily, easily. This one is readily, or is water that does not lather easily. Readily and easily, there's no difference actually. Readily or easily. Easily with soap. Now, I will say lathering means formation of foam. Now, I don't know if I'm pronouncing it correctly. In English, I don't know how it is pronounced, but it came, I don't know, we are okay. I think we're okay. Foam. You know what I'm talking about, yeah? Yeah, that foam, this one. Ile wenye watoto wanapenda kucheza nayo hivi, ukiweka omo kwa maji na ufanye hivi inatoka, this one now comes out, this foam. So if water does not easily form this foam, we say now that one is hard water. And the ions that are responsible for that are only 2, which is calcium ions. So it is this one and magnesium. Sorry, James.
I was saying had magnesium ion.
Yes. So those ones are the ions. Those ones are the notorious ions that make water now hard. Hiyo ndo ions inafanya sabuni, mama anasema, or for the women who are here, unasema imagine mbaya. I know people you have experience with people staying at home that imagine ishimo or this water that I got today ni mbaya, haishiki sabuni. That on now we say hiyo maji that is called hard water. Ama hii maji yenye tumetumia leo imemaliza sabuni. Those ones now we say it is hard water, and it uses a lot of soap before now itoe nini the foam. In our language, I don't know, it's not making sense even me to say the word. but it is that one. I think everybody has understood. So add water. Now, there was a time that I asked a student, what is soft water? I have not described that one here. So actually, who can say what is soft water? Eh?
Hiyo form kwa Kiswahili ni pofu, yani haitoi pofu.
Yes, thank you very much. Pofu. Haitoi pofu. Thank you very much, James. Haitoi pofu. Maji yenye haitoi pofu ndo add water. Sasa tuwezi describe kwa Kiswahili tuseme maji haitoi pofu ni maji ngumu. I know it's all making sense. So you say add water ni maji haitoi pofu. I think that one is better. So I was asking the other time I asked a student, what is soft water? Let me just direct the question to you directly. What is soft water? What is soft water? Mtu aseme tu randomly, what is soft water? So then we continue. Yeah, I think somebody has texted in the group. Let me just check. I hope you can also see what has been posted. So window, yeah, window. That one is correct actually. Okay, there's another definition which is easier. This one is good. Window, thank you very much. Op. So he's saying soft water is water that does not have magnesium and calcium ions. Now, I like your answer first of all. Op. There's a reason why I like your answer. If you are very sure that you have a problem with identifying how to write ions, magnesium ions as 2 positive. If you write Mg positive, it becomes wrong. So kama uko sure kuna shida itatokea, please andika in English the magnesium in full. Andika the symbols, so andika in full, which is good. There's another definition I'm looking for. Actually, I want the definition of soft water. Another easiest definition. Before I mention that one, as we continue to think about that one, I want to tell you something. Now, I will not talk about these ones because if I talk about these ones, students will start seeing me in a certain way. So I don't want to talk about this one. So okay, that one is correct. Again, is water that has very low. Okay, actually, most of the water that we are using, including the distilled water that you are using in the lab, have very low amounts of magnesium. It iko nayo lakini ni kidogo sana. So that one is still okay. There's this definition that I want. What is the opposite of hard water? What is the opposite of that statement that we just mentioned? I want you to go back and say, is water that does not lather readily or easily with soap. What is the opposite of that? If you remove does not, that is actually, if you cancel out this one, let me just cancel out so that you see, and then you read the statement. So if I remove this, is water that lather readily with soap, and then I remove this one, I make it soft. So if you, in fact, your definition is the best, I like your definition since it will guide us. So I think somebody has texted something. So I hope you can see what I open. Nikki open. So yeah. So it's something that lathers easily with soap. But your definition, the reason why I would prefer you to use the definition that you gave is because hautasahau nini ions zenye ziko kwa add water. Juu ukisema that lather easily or that does not lather easily with soap, most probably you will get confused about the calcium and the magnesium ion. I think that will bring a problem. So both all of the definition, but the easiest, kama ukisahau ile magnesium ions and calcium ions in the process of doing the definition, just do the opposite of hard water. You say it is something that does not lather easily with soap. Now, what do we mean by does not lather easily with soap is it forms a certain coating on the water or on the clothing or on the soap, depending. And now that soap, now that coating which is in solid form is a precipitation, and it is normally called scum. I'll give you an example of what a scam is. Now, kuna time yenye unaosha nguo na kuna kitu inakaa juu, ina float. Yenye sio uchafu, you don't even know what it is. Lakini inakaa juu, ina float. That one actually is what it calls scam. And that scam only occurs, unaonanga ikiwa maji ikiwa peke yake, it doesn't occur. Ukiweka sabuni kidogo kwa nguo na uache, you will see something floating. Isn't it true? So utaona kitu ina float. When that one floats now, we call that scam. And it is because of precipitation when you had a salt. Actually, no, when you had soap, not salt. When you had a soap, when you had soap to water. Actually, this one is soap, eh? Hii ni sabuni, eh? This one is soap, the one that is prepared.
You scam.
You can say something, James.
Yes, I wanted to make it clear in Kiswahili.
Please do.
About the scam. Ni kitu kama mabaki ama masalia ya sabuni ile ina float juu hivi.
Yes, that one sasa. That one. Hiyo venye imesemwa tu hivyo, ile yenye ina floating juu hivi na inakaa vibaya. I don't know, I don't like seeing it myself. So hiyo yenye iko juu sasa yenye ina float, that one is scam. So we have soap. We have two types of soap. So I'm just going to mention it. We have two types of soap, and most of the soap normally has sodium ions. Sodium ions actually is very cheap. Wale, I know most of you wanaunda, if you have ever tried, kuna hii sabuni, the liquid soap. Now, people normally get confused between soapless and soapy. Soapless and soapy. Those things are different. Actually, yenye tunaunda is not actually soapless. We normally do the soapy. Kama bar soap. It is like a liquid bar soap. So most of the things that we do, we talk about those ones. But I will explain. I'm not talking about this one today. I'm talking about, we have two types of soap, soapy and soapless. So in a sabun, we'll talk about the ions. This one is R. We normally call it R, the alkyl group. In the alkyl group, and this one is also alkyl group. So when they combine, the ions that were inside, or what was in the, will be displaced, which is ions now. The sodium ions will jump out because you know sodium is very reactive. So itatoka na ipeane nafasi to calcium and magnesium ions. And when that one happens now, this one, E, where the cursor is, the C17, H35, COO enclosed to calcium is now the scam. I'm not going to touch on these ones today. I'm not going to tell you soapless, soapy, and the rest. So that one is, so when this one happens now, that floating thing is scam. And this one is scam. And this one, I'll tell you where we'll find this one. This one is in Form 4, Organic Chem 2. So when we'll be dealing with Organic Chem 1, we'll explain what these are. And then we go to Organic Chem 2, I will now say, is this one a soapless or a soapy? So there's no need of even touching those. But I wanted to show you what scam is. It is a solid. It becomes solid. And then we'll see it when we're dealing with the removal. So we have two types of hardness of water. We have temporary hardness and the permanent hardness. If you have a question, please, you can ask any place. You can do the text, you can do the way James, I think James is doing a good job. So anywhere. So we have two types of hardness of water. We have the temporary and the permanent hardness. Now, the main difference between the two is well explained in this one. But now, I don't know if it is in your books, but it is actually the KLB. I don't think they factor in this one. Now, I want you to see this one. The KLB will tell you that temporary hardness is hardness that can be removed by boiling. Permanent hardness is hardness that cannot be removed by boiling. Actually, equal to temporary removed by boiling. Permanent not removed by boiling. I don't know. Is it making sense? It is easier. I think it is easier to mention it that way. Now, mine, I did further research and then I discovered that calcium hydrogen carbonate makes water temporary hardness. Now, when you have now the carbonate itself without the hydrogen, it becomes permanent. But let us use this one. So actually, it is due to presence of dissolved hydrogen carbonates. Hydrogen carbonates, but remember, it is hardness is only brought by calcium and magnesium. That's why I had to mention calcium hydrogen carbonate and or. I want to say and or because add water inaweza kuwa na calcium ions na magnesium ions at the same time. Saa ingine iko na calcium peke yake, or time ingine iko na magnesium peke yake. I hope that one is okay. So now the reason why it is called temporary, it is because it can be removed by boiling. So temporary water hardness is the hardness that can be removed through boiling. Iko sawa? So when you boil, actually, action of it on salt. Action of it on salt, I don't know. I don't think I was the one who told that. Somebody else must have told that one. I would have remembered. So calcium, when you decompose these ones, that is what happens. And when that happens now, you can precipitate out the iron. So when you boil, it removes that thing. The scum will not occur because you can precipitate out actually calcium ions by removing it as a solid. Remember, I was the one who taught solubility of salt. So we said all carbonates are insoluble except group 1, which is potassium, sodium, and of course ammonium, which all of which salts are soluble. So when you remove, you must make sure that this one is a solid, so it will be precipitated out, so we'll have our water. Now, if the water has this one yenye iko chini ni how it is made temporary add, how it is made temporary add. So that one there's no problem. And I'll tell you something about temporary add water, which you will also mutaona kama ni ukweli ama ni uongo. So if this one was in water already, it becomes very hard to remove. So we need something else. But if this one was in water and you boil, you can remove this one as precipitate, as a solid, which is normally called precipitate. So temporary water is formed when water particles passes through or penetrates limestone, kina gypsum, yenye iko na hizo vitu. That one is how it is formed. Now let me talk something about your water, hard water. Now let me ask you this. For those people who have, I don't know if we all come from reserve. Some of us maybe walizaliwa town and that is their reserve. Water from reserve, ile yenye imeenda kuletwa mtoni. I come from my reserve myself. Yenye imechotwa mtoni na yenye imechotwa tap in town. Which one is sweeter? You don't have to answer me. Just think about it. You will answer before I continue to permanent. Before I continue to how we remove this hardness. So permanent water hardness. This one now, I want you to see. I want you to see what is happening. So ile ingine tusema ni hydrogen carbonate. And when you hit those ones, it decomposes. Iko sawa mpaka hapo? Now, the other ones, when you talk about the other ones now, it is due to presence of dissolved calcium sulfate and all calcium chlorides or magnesium sulfate or chlorides. And this one now, the difference that brings in permanent and the temporary is, it is a type of hardness that cannot be removed by boiling. Actually, in KLB, that is the definition of permanent water hardness or permanent hard water. It is something that cannot be removed by, or it is hardness that cannot be removed by boiling. So kama inatolewa by boiling, we say it is temporary. Kama haitolewi, we say it is permanent. Yeah. So it, of course, it can be. There are very many methods of doing that one. We have chemical treatment. We have distillation. I'm not going to talk about that one now. So we are going to talk about that one uko chini. Now, I'm not going to tell you how it is. Nobody will ask you those advantages of hard water. That's what I'm saying. Like, when we started this subtopic, I said the advantages of hard water outweighs its disadvantages. We will see about that one. So, number one, it provides calcium. So, because it has calcium, we need calcium in our bones and in our teeth. So, it is essential for strengthening of bones and teeth. So, that one is very good. That one is one of the best application actually, because watu wengi kama hakungekuwa na calcium hata huwezi tembea, because we depend on our bones, and also haungekuwa unakula chakula nyama and the rest, or miwa. Let me use miwa. Haungekuwa unakula miwa because I know most of us chew that thing. So ungekuwa unakula miwa because now I can imagine if your teeth is weak, I think it becomes a problem. Now, hii ni vitu ya wazee. I don't know. I don't take alcohol. So it is used in beer brewing. I don't know. Most people have asked me out. This one happens. I wanted to do a research on this. I'm yet to. So it improves wine and beer flavor. Now I don't know about that. If somebody has an idea, we are free. I think we are old enough. So it improves flavor. I thought flavors is added. If I wanted a flavor, I will add something. For example, if you want passion flavor, you add passion. So I don't know about that one. Another thing that is very important, especially for transportation of water, Eldowas, Nawasco, I don't know, and the rest, it leads to formation of lead carbonates and lead sulfates, which are insoluble. I want you to remember, the reason why we combine these ones is for you to remember that lead carbonate is insoluble, lead sulfate is insoluble, first of all, which cause the inside of the pipes preventing. So it prevents poisoning by lead. That is number one. Alafu ina prevent also water corroding the lining of pipes. You imagine inaweza kuwa na chemicals, kama for example, if the water has some chemicals, for example, I don't know, some water has chlorine. So chlorine actually can corrode a pipe. When we know that HCl corrodes surfaces. So chlorine at high concentration will corrode a surface. So to prevent here, we have the lead formation of insoluble salts. That is carbonate, which is insoluble. Actually, lead sulfate also is insoluble. So that one is very important. Yes. And then the last one, advantage. I don't know if it is in the book. I am not aware. But calcium ions are normally used by aquatic animals. For example, the turtles. Is it called the turtles? And what do you call these things when you are the shells? Either shells, snails or something. I don't know, inakwanga snails, but I don't know what the seashells. The seashells. The seashells now are formed by calcium. So calcium is very important for those animals. Disadvantages of hard water. Now I want you to see the advantages, and then you compare with the disadvantages. Number one, in a waste soap. So you use a lot of soap. Now, me myself, I think I prefer to have teeth and strong bones and buy more soap. I don't know what about you. Foam scum, which stains white clothes. I don't know. I'm not a fan of white clothes. I only have maybe 2 or 1 shirt. So if scum is formed on my cloth, I don't have a problem. But as long as I have teeth, which is white. So it forms scums, which stains clothes. Actually, it stains clothes. So now, this one normally is what inakasirishanga most of the ladies. But I don't know if it affects us men. James will tell me. The position of far ni ukichungulia kwa birika. Let me use that word. Ukichungulia kwa birika, hiyo mudomo ya birika. I know people don't use birika anymore these days, especially the metallic one. unapata imepata kitu fulani ya black yenye haitoki na iende kwa chai. That one is far, which reduces the efficiency, especially of the boilers. So lazima ioshwe after some time. Sometimes it results, the fire itself inakuwa mingi mpaka ina block water pipes. I don't know the disadvantages and the advantages. So you can, so I don't know the position of fire in the boilers. I hope you have understood that one. But those ones are very important. Now, before I go to something else, I think the next topic is how we remove water hardness. Before I go to that, please, let me just repeat those 2 words. Please, humbly requesting, know at least 2 advantages and disadvantages. Jua mbili. Ya kwanza, I think it is very easy. Now, I normally arrange my things so that it becomes very easy. Waste stop is very easy because inaharibu sabuni. And then I go to foam scums, which stain clothes. Those ones are very easy. I think you can remember that one. And then ingine, calcium essential and beer brewing. Please remember beer brewing and calcium for bones. I think this one also is in bio. Yeah. This kind of questions, we don't ask more than 3. It is very hard for somebody to ask, name 4 advantages of water. That is wasting a lot of marks. Because, and I'm wasting the students' time since I am supposed to give a lot of things. Chemistry is very wide, and I only have to set 80 marks. 80. So I will not ask you a lot of questions. And you can also see how the questions have been structured. Alafu uone kama wanaulizanga a lot of them. Somebody has said something. Let me just confirm and then we continue. Please, no comments. James is saying what were beer. Don't forget about brewing. Yeah, it is beer brewing. That is an advantage. And then of course, maneno ya meno na bones. Very important. Now, the next thing is how do we remove this hardness? Now, in my notes that I have, hard copy. This one actually is the soft copy. I remade the soft copy notes. I remade restructured. Let me say restructured my hard copy notes. Side that I have named. I'll help you, and then you can do it for yourself. So I've said methods of removing water hardness. Now, what I have done, instead of doing boiling, what I've done is, I have written methods of removing water hardness. Alafu nikagawa. What I've done is this. Especially when you're doing revision. So nikachora methods of removing hardness, and nikachora hivi. And then I wrote temporary hardness. Temporary hardness. And then we have permanent hardness. This one is very easy when you are studying. So kama unaenda kuingia exam na unapaswa kuharakisha because time is moving. You have around 30 minutes. So this one is very good. So you have temporary hardness and permanent hardness. So you name those ones that are removed by those ones, those processes that can remove temporary hardness, unaziandika huku. Zote zenye zinatoa permanent unaziandika huku, because you have those ones that can only remove temporary hardness but cannot remove permanent hardness. But most of the processes that actually remove permanent hardness, kama inatoa yenye ni permanent, obviously hiyo yenye sio permanent itatolewa. Yeah. So you should do this diagram. It will help you a lot. Trust me, it will help you a lot. So I just wanted to show you how it is done. So methods of, so number 1, boiling. Kila mtu anajua boiling ni nini? Kuchemsha maji. So when you boil water, it removes temporary hardness only. And the process is repeated now, where we have precipitation of the calcium carbonate and the magnesium carbonate. So those ones are removed. And these are, now there was I asked this question. I normally take this one, venye tu nimeandika hivyo, nafunza hivyo, so that I have a chance to ask students, why is boiling not used in large scale. Yani nakuwapea hivyo kila kitu, and then I will ask you why is it not used in large scale. For example, maji inatumika Nairobi ingekuwa inaboiliwa ya kila mtu ndo ilete ikiwa safi, would it have been a cheap process? So it is expensive. So it only removes temporary hardness. And the process of removal is when you boil hydrogen carbonates, it will decompose to produce calcium carbonates or magnesium carbonates in that case, plus CO2 plus water. So you would have removed the calcium as a precipitate, as a white precipitate or as a solid. Now, addition of washing soda. Now, before even I continue, I want to give you a difference. We have washing soda, and is it not baking? There's something else. Washing powder and washing soda. Is it washing powder and washing soda? Those things are different. Let me repeat again. Washing soda, washing powder. I think there are two things that are normally mentioned. Washing soda and washing powder. Maybe to tofauti. So we have the addition of sodium carbonate. So that one now will go to the right side where we have permanent hardness. So we say it removes both types of hardness, and it softens water by precipitation. So it will precipitate out. The process, what we're interested in is removing the ions of calcium and magnesium. So how we remove those ones, we make them solid. So when it is solid, the water will be liquid and we have a solid. So hizo vitu mbili haiwezi enda pamoja. So solid itabaki kama residue, and then the water will go out as a liquid. So that one removes both hardness. So and then it is precipitated out. So it is, I can ask a student, why is this method preferred for large scale? And we have the reason. It is relatively cheap because I just have to add niweke kwa tank, kama tank, even a million liter tank naweka how many liters? I can add maybe another 100 liters in the same, and the tank will be clean. Actually, yes. Distillation. Actually, for those of us who have gone, I don't know. I think maybe you have somebody who works at the university. A distillator is very expensive. Actually, it is expensive. Most of the high schools do not afford it. And if you have it in a certain high school that you have ever gone, then that school is rich, actually. But these things is normally for the university. A distillator is actually a tube. It is tubes, and the water goes round and round. But those ones, it has something inside. So let me just explain that one for now. So actually, it removes both temporary and permanent hardness. This one, so ingeenda to the right side. So it is heated in a distillation apparatus. So it just goes round and round. So it will distill out the water, leaving out salts as actually ukiona hiyo kitu inakwanga turn brown inside is because of those solids or those salts. And then again, this method is expensive. Yeah. So that is why you can find distilled water is being sold at 2,000, and it is in 20 liters, going for 2,000, which is a little bit expensive. For me, that is expensive. But distillator itself is expensive, and it is, I don't know if they brought in something. It is made of glass, which I don't know. I don't trust glass. If you do, I think we are different people. I don't trust glasses, especially for those things. Hello? Are people still in class? What happened? People just, I don't know, I can't see people anymore. Can somebody say something? Somebody say something? I thought, I needed somebody to say something. What happened? What happened first? Yeah, there was a time I didn't see people. All of a sudden, everybody disappeared. So anyway, there's no problem. But the good thing is we're in. Yeah, I was worried. I get worried. So we are addition of calcium. So I was saying the distillator is very expensive. So number 4 is addition of calcium hydroxide, which is normally called flake lime. Now, it is very important for you to remember these names. Some of the names, not all of them. Right? It is lime. Sometimes it is normally called lime water. I want you to remember the uses of lime water. Lime water is normally used. You can see the screen, Yeah, because I normally get worried when people cannot see the screen. Lime water, there is a use for lime water. Another use is normally used for test for CO2 gas or carbonates. Normally used to test for CO2. So it forms a white precipitate. So it is very important for you to know those ones. I don't know. Let me check. You cannot see the notes. Okay. Let me stop sharing first, and then I share again. I think that one is better. Yeah, so all of a sudden I couldn't see people. So I was worried because I need to see people. I think she's saying I'm a patter. I think people can see now the screen. So let us finish this one. Okay. Thank you very much. Okay. So addition of sodium, select lime, or we call it lime water. So addition of calcium hydroxide. So this one normally it really removes temporary redness. So you can to the left side. Are you seeing now the importance of those things? So these are normally precipitates out calcium ions as calcium carbonate. So it only removes the reason why I think the reason why it is even called temporary is because it only removes calcium ion. So most probably the water would be having calcium, not magnesium ion. So it normally precipitates out calcium ions this way as a solid. So it only removes temporary redness. Addition of aqueous ammonia removes temporary redness. So we have 3 already that you already know. Number 1 is boiling, addition of lime, and addition of aqueous ammonia for removing temporary redness. So sometimes the question goes as, apart from addition of ammonia, name other 2 methods of removing temporary redness. So it is very important for you to remember those ones. So remove temporary redness only. You are those ones is precipitates out. Those ones. And then now we have, I think this one was in the KCC, ion exchanger. Use of the ion exchanger, and this one removes both temporary. It removes both temporary and permanent. And this one is the one that I love the most. And it is normally tested a lot, such that it makes me worried of the students if they really understand. I normally repeat, the first thing I repeat, by the way, after completion of the syllabus is methods of removing water hardness, the way I just mentioned, unagawa hapa na hapa, and then I do ion exchanger. The ion exchanger kama imejisimamia. So you normally removes both hardness. So what we do is we have something like a column or something like a tank, lakini ndani ya tank we have branches. Let me say we have branches, vitu zime branch hivi meenda, we have one pali maji inapitia katikati, but we have branches hivi. Now in the branches, which is normally called the column, is normally called the column where the ion exchanging is happening. From the name ion exchange, it is ions being exchanged. So in the process, as water is passed through the column filled with some it is normally filled with complex ions, sodium compounds, where we can say sodium X, where X is the complex. So instead of using, or we can even use A, Y, there's no problem. So we can be represented by the formula. Complex, those complex salts now, those are sodium, aluminum, silicate. This one, silicate, is normally, it has silica, it has aluminum, it has, yeah. So those ones are complex salts. We don't even have to know them. That is why we have denoted by letter X. Now, as that water passes through the column, magnesium ions exchanges with sodium ions in the column. Now, what tulikuwa tumesema, the magnesium ions and the calcium ions are the one that makes the water hard. So kama imebadilishana, and the process that happens is this one. So venye inafanyika kwa hiyo column, I don't know if I have the column hapo chini, but I'll see. So what happens is this one and this one. So huyu anakuja anachukua huyu, yeah, and then the sodium remains now. So we have the sodium ions imeingia kwa maji, na hawa wanabaki kwa hiyo column, inashikiliwa na hiyo column pali sodium ions ilikuwa. So we say those the complex that column ilikuwa na those complexes, lakini ilikuwa na sodium. So ndo tunachukua hiyo the sodium is given to the water, alafu calcium yenye ilikuwa kwa maji inaenda kwa that column. So in the process maji itatokea huko chini sasa, ikishapita that column will be water with sodium ions, haina magnesium, so it will not be having this one, na haina calcium. And what do you know about hard water? Hard water has magnesium and calcium ions. So kama imetoka kama haina hizo mbili, it doesn't have calcium and magnesium, we say now that one is soft water. So that is how actually the ion exchanger works. Let us continue. After some time, ukitumia hiyo column for a very long time, utakuja upate haifanyi tena, haitoi calcium na magnesium ions tena, juu zimeshajazwa. So ikishajaa imekuwa mingi, it becomes now non-functional. It doesn't clean the water anymore. So what we do, ikishakuwa converted to calcium ions and magnesium ions, so haina ability tena ya soften water. So what we do is, it can be regenerated. So what we do is we flush brine. Brine is actually concentrated sodium chloride. Okay, flush that brine, the same thing will happen again. The ion exchange will take place. So let me just continue. Let me process kidogo chini, and then we finish. So what happens again is the ions exchange will take place now. So the sodium that is in the brine, and you remember it is concentrated brine or concentrated sodium chloride. So juu iko concentrated, it will also exchange the ions. So it will be giving, the X will be taken by the sodium. So hawa wawili watakutana, huyu na huyu, forming this one. So we are returning back our column. Alafu sasa ile ingine inatoka kama calcium chloride. So inaenda kama calcium chloride, but we are not putting water. Hiyo time ya kuosha sio maji. So water will not still get calcium chloride. I want you to go and research. I'll give you an assignment today. Because I don't know if we'll meet. I'll give you another assignment so that but I'll give it as ya kusema tu. So what happens here now? What happens here? Kumbe I have that thing. So when we flush down, inakuja inakuwa hivyo. So what happens is when it is hard water, it contains calcium. Now you see now this column inside are sodium ions, nini sodium ions. Now when water comes through, ikitoka hii calcium na magnesium inachukuliwa, maji inatoka na sodium ions, which is very important. Unless there is a query. Effects of hard water on soap, I'm not going to do it today because I'll do it somewhere else. Iko sawa? I'll do it somewhere else. I hope you have understood something. So the most important thing, I don't know, just a concern, to be honest. Effect of soap is because you have not done what? Organic chemistry. So before we leave, all of us, let me just read this one. My internet now is becoming a problem. I don't know, somebody. Okay, no problem. No problem. I just remember. So just a concern, to be honest with you, Mwalimu, many of the students haven't understood how to draw the solubility graph. I therefore request you to take as a step by step so that each and every student can get it right. Even if it means that we repeat the topic once more, the better. I agree with you, James. I can't afford. I don't. Now, forget about the hardness of water, but please do not lose marks on drawing of graphs. So what we do, hata nyinyi mtanipea suggestions. On Wednesday, we have a class very early in the morning. I don't know if people will make it. That is from 6, is it 6 to 7? It will be an open forum now. Nimesha soma the concern of James, so we're going to do a graph. Now, for the sake of graph drawing, do we do it on Wednesday morning or we do it on Saturday morning? Open forum, muniambie tu, we do graphs only. 1 hour is enough. So Wednesday morning we can do the graph. Now mupeane suggestion sahi because maneno ya graph actually mimi siwezi kubali hata mimi. I better repeat that as solubility curves. Actually, I always repeat, even in my school, I repeat that one. So somebody to say something. Now, as we leave, as I wish you a good night, blessed evening until we meet tomorrow. We meet the next day. So maneno ya graphs. Anybody with something to say, you can speak, you can unmute yourself. So so they're saying Saturday morning people are somehow settled. That is from Maura. So anybody with another suggestion?
For me,
Yes.
for me, I think Wednesday morning will be okay.
For Wednesday. Yeah, I think. Yeah, agree to
And,
disagree, we vote. Yes, James, continue.
I don't know if we can get a board.
Sorry?
I don't know if you can be able to get a board so that you will be illustrating
Yeah.
as we go by.
We will do that one actually. I know I will access the board here.
Yeah, that one will be much easier for us to understand.
Yeah, we'll use a board. We are
questions.
using a board. We'll
And
use a
if
board. We'll use a
possible,
board.
if you can be able to get many questions concerning the same topic.
Yeah, I have a lot of questions actually. Yeah, I shared the questions, but I'll still share them again with this group now. So nitatuma kwa group.
Yes.
I had sent some topics, questions of all topics they are Form 4. So I'll still do the same.
Okay.
But we'll share that one. Yeah, graph we'll do using a board. You know, now the problem is I was teaching the theory at the same time graph. But if you go to graphs alone, I use the board.
And I also have a suggestion to my fellow students.
Okay, it is okay.
If you can't understand it here, you just look for Mwalimu
Yes,
to
yes. I'm
take you
actually
through,
available.
to
Yeah, I'm
understand
actually
much
available
better.
through. Yeah,
Yes,
yeah.
we'll
Please.
be very
Yeah,
much
that
happy
is.
if each and every one of us understands the topic.
Yeah, me too. I really want everyone to understand. It is
Yes,
even better for me to use my own time just to
yeah,
explain to you mpaka ushike.
correct.
Yeah, but it is very important for you to understand.
Usichoke, like me, I'll look for
Yeah,
you.
please do. My number is there. My name is Nixon. I don't know if I changed my name, but I think it is the same there. If it is not, I think it could be my email. But I pick calls. I answer messages, both WhatsApp
Yes,
and the normal text.
that's great.
Yeah. So I about that one. So Mwaura, you can agree, and then you just tell me if it is on Saturday morning or Wednesday. There is no problem. Otherwise, have a good night, and for those who have not taken supper, have a very good supper, nice supper, and then until we meet on Wednesday, you have a fruitful week. Thank you very much.
Okay, thank you. Good night, teacher.
Good night.